Well, hi, and thanks for joining me here while I go. I think this is my third video on the PET computer that I have here, and this one, take a look inside here and see if there isn't something I can do about making this work. This does not appear to be working. So I got no power into it right now. This of course is the disk drive for the Commodore, the PET computer you see behind me. And I'll apologize for the hum and buzz that was on my last video. I have a temporary video setup here that I'm using while I'm doing some renovation work in my shop and nearby my shop, the other part of my house. So I just grabbed my listening post spot here to do this work. So I really don't have a workbench around me or anything. Okay, I think. Oh, there go the screws. Okay, let's see if we can get this off. Tricky at the back. Ooh. VO. Okay. Actually, I have a disc in here. I should take it out. So this has to come off. Just a couple screws on the other side here. So this is a fairly smart disk drive, you know, as they go. This is a smart one. I don't know about regular IBM disk drives. I don't think they're like this. And by smart, I mean it has computer processing components in it. It's more than just a drive. Red wires here. Try to leave everything intact as much as possible. Wow. Okay, there's a little more in here than I was actually expecting too. Wow. Holy smokes. And, oh boy. Lots of stuff to go wrong in here. These big chips are in sockets. That one. That one. They're all in sockets. The rest I can see appear to be soldered to the board. Now what this machine did when I turned it on, what it should do is it should run for 2 seconds. It should basically run the motor for 2 seconds and then just go silent. There's a green light and red light on the front, and they should both be on for the 2 seconds, and then the red light should go off, and it should sit here quietly at that point. Let's just try it again. And I believe during those 2 seconds it's doing some kind of self-check process. Oh, my other computer. Not to worry about that. Okay. Power's in. The computer itself is disconnected. I've taken this big plug out of the back. So this is just sitting here with a power connection, nothing more. Okay, we'll flip it on. The 2 lights to watch are right here. Here and here. Here we go. I'm guessing you can hear the motor spinning. I don't hear anything else. It's not exactly the kind of thing I like to troubleshoot. Can't imagine this is going to help what I'm doing. So, you know, when I look it over, it looks fine. Nice and clean inside. There were some voltage measurements that could be taken. So look for, I think it was 5 volts for sure. And the other one, I think, is to run the motor. And if the motor's running, I can't see there's a problem there. So there should be a couple of voltage regulators. You know, there could be a lot more circuitry down under this board I don't even see here. But I would guess the power supply is all this. There's some interesting stuff in there. Let's take a closer look. There we go. That's kind of interesting what's going on there. All those resistors and all those capacitors. I assume those are resistors. You know, they might be diodes. Well, there is a little bit of dirt here, isn't there? 6522, 6502. So I did read the 6502 chip could be responsible for this behavior. It would strike me almost anything could cause this. This is actually just going to the lights here. It's just feeding the green light. Red light's down in here. What can we see up in there? Oh, there's the motor spinning. Just waiting for autofocus to autofocus. There we go. Looks really good. Lots of stuff. Lots of discrete components in here. Well, okay, so I'm going to turn it off because I don't think it's going to change. And maybe what I'm going to try doing is reseating, starting with reseat this chip, the 6502 chip. I really don't like doing this kind of thing because I think I'm more likely to introduce trouble than solve it. That's what I think of doing this kind of stuff. This is probably the rectifier here. It's pretty warm. Not exactly the right way to pull on a chip either. So I got it to move. the chances that did anything? What are the chances? Chances are pretty well nil. I gotta go find myself a voltmeter and look for that 5 volts in here somewhere. Okay, and here's my meter before I get going here. Thank you to whoever it was, I'm sorry I can't remember your name or your handle, who sent me a link to a page where someone describes some technical details about how to work on one of these guys and what to check for. So in that document it says, hey, take a look for the 5 volts and the 12 volts that should be in here, and take a look at if there's trouble with that, look at the source, which should be 20 and 10, I think. 10 for the 5 and 20 for the 12, and see what's there. So let's try some of this. Okay, I'll put on my meter. Maybe if I put it here, where? There we go. Okay, better put it on volts. 20 volts DC. Switch on. Okay, so I think the place to look is here, or here, and not very good, or here, or the other side of the diode there. It's a little odd. I'm really expecting to see something. The motor is running. How about on this big capacitor here? Why is it every time I connect I get something and then I get nothing? It's like a bad voltmeter lead here. How does that work? It says plus right there. There should be something on this. I think my voltmeter lead is a dog. Let me get another one. Let me get the right leads for this meter. Well, and there's a chance here that I'm actually not making a good ground connection onto here. What I've done is I've just taken in this case now with these new leads I'm about to use, I've clipped on a clip lead basically to the metal chassis, which from what I can see should be good. But I'm getting some pretty weird responses on the meter here. Let's find out what happens now. Okay, and also I've left this running now for a few minutes anyway, and there's no smell of anything overheating, which is a really good sign. Okay, now let me clip on the ground here. Okay, let's start off with this capacitor. See, I got exactly the same response. That's wow. Let's go right across the capacitor. Right across it. There we are. That's not supposed to be 12 or 5. 17. How does that fit into the picture? I don't know. So it could be I didn't have this connected where it's going to do the job here. Yeah, so that's all it was. How about over here? It's kind of surprising. There's another big capacitor. Let's check across that one. Okay, negative here. Positive here. Well, it looks like 10 volts right on the money. So that's what's running the motor. So there's the 10. Where is the 5? Well, the 5 appears to be the problem. I'm going to guess the 5 should be across here. Instead, we're getting 17. What am I talking about? Okay, let's look for 5 on one of these chips. See if I can find it here. just pick any one chip. Start in the corners. 3. What is that? 3.7. That's not... Hey, there's a 5. Okay, so there's 5. So the 5 and the 10 are in here, regardless of all that malarkey I did here. So with the 5 and the 10 in there, it's not really a power supply issue. Now another thing, apparently there's a lot of small tantalum capacitors in here which are prone to failure, supposedly. So I can see them all here. And apparently they can be pretty exciting when they pop, but that means it's also quite noticeable when they do. I don't see any evidence of any component having failed here. What's going on with that one right there? Is the top blowing off that? Okay, let me fix the focus on this camera because it's driving me nuts. Just bear with me for a moment here. I just have to bring up the control box for it. Dialog box. And we're going to turn off autofocus. And we're going to focus it right up close. Okay, what do we got here? No, that's just black paint on there. Yeah, it's nothing. See, I'd be floored if I'm looking around like this, I'm going to find something. But, you know, I can't tell you how many times I've been floored by finding stuff like this. I'm also looking at the quality of the solder. It looks fantastic. Everything looks fantastic. This is operating right now too. Those diodes and any one of these capacitors might be bad, but it's digital equipment. It's not analog audio type stuff. So, you know, I think the digital signals can survive some weak electronics fairly well. I think. I don't really know that. That's a weird thing. What's that? I think that's a, it says L13, so I think that's basically that's an inductor done with a, I want to say carbon, some kind of bead on a wire, basically. Oh. The board's in rough shape in here. I'm getting close to the back of the machine. Is it all dirty back here? A little bit. So if the 5 and the 10 are good, I think I'm going to wiggle all these chips that are in the plugged into these connectors. So I'll just do that off the video here. Oh. Okay, let's see, I did each of these 5 or 6 chips one at a time. I didn't lift them right out. I just lift them up a bit and back in. I don't want the pins to come right out of the socket, or you have a challenge getting them back in. I didn't need. Here's the result. And the result is no result. Nothing is any different. I also re-plugged all these plugs. And then I began taking a closer look at some of the solder connections. And I found something that's, a fat chance it's the problem. But let's take a look at it under the close-up camera here. Okay, so this is that row of capacitors, and just behind is this row of, I guess these are diodes here. And I want to look at one of these in particular. Get it on camera well. I believe it's the one numbered 79 there. No, maybe 78. I think it's 79. Appears to be badly soldered. Now you can't get as close a look in this camera as I can with my magnifier, but both terminals on 79 appear to be weak. And more specific, the solder appears to have stress cracked at the connections. Why only this one when there's all these other ones here which look perfectly fine all the way down the line? Go back to number 79. Not looking so good. So, I could hit that with a soldering iron. Oh my gosh, this drive is running. Turn it off. Let me go see if I can dig up my soldering iron here. Okay, my soldering iron here. Now, I'm going to give this a 0.1% chance of fixing this thing. That's 1 in 1,000. Just let this warm up. By the way, if you do occasional solder work, this soldering iron, I'm not trying to sell it or anything, this little Weller soldering iron, cheap as can be from the hardware store, is actually a great little guy to have around. It's nice to use. It's very light. I have to wait for it to warm up though. Wait for the green light. There we go. If you don't want to go out and invest in a big expensive one, this is great because you can cart it around the house. It's just got that little wire on it. Here we go. Never mind that. It gets really hot too. Too hot, in fact. Which one is it now? Second one. 79, number 79. Here we go. I can even get the back one. In doing this kind of stuff, you're just about as likely to introduce a problem as clear a problem. But if you got something like this and it's not working, if you don't do anything, it's never going to work. Well, it certainly looks different. Okay, are we ready once again? Watching the lights, the blinking lights. Come on, lights. Oh, you know what? I unplugged it to plug in my soldering iron. Okay, moments of excitement. Here we go. Yeah, it's not gonna help. Okay, more rugged, abusive treatment here. It's a digital device. If it's out of sorts when I turn it on, even if I manage to, I don't know, manipulate something, and I end up correcting whatever I'm assuming is a bad connection in here, it's already gone sort of past its thing, and it's just not gonna come back to life. Why am I only coming out of one channel? What happened? That's a little better. Okay, lots of little problems here. So it's gone past its check state. It's in a new state. I mean, I can do all I like. It's not going to leave this state. So it's kind of crazy. I think I gotta shut it off. Hey, is anybody getting hot? These are all warm. Every one of these. What's not getting warm? Maybe that's the hint. Pretty cool up in here. I don't really think of chips as getting warm. They all have a little bit of heat, so what's that tell you? It tells you they're doing something? Find something that's hotter than it should be. Well, we're getting nowhere here. Getting nowhere. I have to do a far more serious job troubleshooting this thing, and it's out of my experience zone. Wow, think, man, what else could it be? Should I bother trying to lift this board up and looking underneath? What's in there? Just some mechanics. I think I'm stumped. I think I'm stumped on this guy. I have to do a lot more reading. Just making sure all the chips I've popped up are really popped back down. One more try. No, it's a done. Okay, I'm not sure what to do about that. Hey, thanks for watching, and too bad that didn't work out, but not everything works out right away. That's for sure. See ya. So I've done a little more reading. I've got the manual actually for this drive, the service manual for it, and I'm kind of working my way through it a little bit. What it says is the 2-second delay is triggered by a 555 timer, which is just here. You can't quite see it on the camera there. There's a little chip right here, and it's supposed to be triggered by the 5 volts appearing on it. And there you see the 5 volts. Well, you almost see it. There's the 5 volt setting on it, so assumably the 555 did its thing, but the drive continues to show the red light. So just beyond it here is a set of what's basically 1, 2, 3, 4 transistors, and then we've got 1, 2, 3, 4 diodes, 1, 2, 3, 4 resistors. Now I've already tested this, so I'm going to go through it again. If we're on this end of it, I'll just test them quickly. Here we go. 11.8, 5. 11.8, 5. 11.8, 5. 11.8 and 5. So a lot of consistency there. Don't know what it means, but what does it matter? Now if I test the other side of these diodes and resistors and come back, we can do that. Okay. This is a 0 on the resistor, 11 on the diode. 0 on the resistor, 11.8 on the diode. I'm pretty sure it's a diode. 0 on the resistor, 11 on the diode. Hey, that's not quite 0 on that resistor. And this diode has pretty much a 0 on the output. These first two don't behave like the rest. So I'm going to try to find out. These are all labeled nicely in here. CR16, R42, CR15. So I should be able to find these on a schematic and sort out if they should all be working the same way or not. So I'm in the realm of the 555 timer, which will affect this red light. I'm in the realm in terms of where I am on the board here. Maybe I'm onto something here. Okay, so I've been working my way through the some of the, let's call it the front end circuits of this drive. When you first turn it on, the drive is in a sort of unset mode. I mean, who knows what charges are anywhere. So one of the things this machine wants to do is, after it gives a second or two for all the voltages to come in, it then wants to throw a reset onto the machine. That's what's going on in the first 2 seconds. This timer times out those 2 seconds, and at the end of it, it throws the reset forward onto, I think it's this chip here. So I've been studying the 555 here. Here's a few things. Okay, when 5 volts are on this pin, the chip should be counting and doing its timing. There's the 5 volts. When 5 volts are on this pin, this is the power to the chip. This is pin number 1 here, which is grounded. So it's pin number 3 that carries the output, which should go high after 2 seconds. And I'm touching pin number 3 now, and I'm seeing a 0 on pin number 3. Okay, just a wee bit further on is an RC time constant circuit here, made up of a capacitor right here, a little hard to see maybe, and this first resistor. On one end of this resistor should be 5 volts, there it is. The other end should be high, I think, at 5 volts also, I think. It's at 0. This capacitor is connected to that zeroed end of the resistor and goes to ground. If this capacitor is shorted out, then that could be the whole problem right there. So I need to test this capacitor. Let me turn it off here. Now I'm going to start putting test voltages on it. I better just go peek at the circuit diagram here before I apply a test voltage right into the chip and make a mess of things. Okay, quick peek at the schematic I'm looking at. These are hand sketches of circuit sections through a manual, and they're hand-drawn sketches, clearly not done by a draftsperson. So I shouldn't have any problem at all checking this capacitor. So I'm just going to look for a short, just simple as can be. Okay. Is there a short on this capacitor? 600 ohms. Why would I read 600 ohms through this capacitor? Wow, that's very much like a like reading across a diode. Looks like the forward voltage drop on a diode. Okay, go the other way. What kind of a capacitor is this? I get that in one direction. See, I could be looking back into the chip a little bit. I get that. If I could put the circuit diagram up on the screen for you to look at, I would, but I just don't have the capability here. I'm going to go take another look at it. Just try it. As far as I know, that capacitor I'm testing is connected simply to ground, but the high side connects to the resistor here and also connects to the chip. So maybe I'm just reading inside the chip here. Okay, let's attempt it with this device here. I'm going to try to test the capacitor in circuit. Just test it with another instrument here. There we go. Okay. Let's see what we have with this. It's going to tell me it's a diode. It's a capacitor. Ooh, still testing it. Normally, the test is done pretty quick here. No unknown or damaged part. Well, that's a little bit surprising. Let's just try it again. I mean, it is still in the circuit here. You know, it's as confused as me. When I used my voltmeter, it left me scratching my head. This thing's going the same way. Again, the testing is going on for too long a period of time. No unknown or damaged part. Well, that's two tests telling me this capacitor might be bad. There's it also there's also some logic behind that being the cause of the problem. The logic being that the state cannot be passed, you know, the high or low state cannot get past that capacitor, the high state anyway, because it's holding the far end of this resistor down. And so get this guy out of there and stick in another one. That's my project. Okay, so I'm going to try to actually unsolder this from the top of the board just by heating up one leg at a time and kind of wiggling it out. We'll see. I don't want to lift the board out if I can avoid it. Not because I'm lazy, but I just don't want to do that much work. Okay, here we go. This soldering iron gets extra hot like I mentioned before, so it's a good one for this. And I don't think I'm going to succeed. There. succeed with that. So alternate plan 2, and we'll nip it off, leave the wires sticking out a little bit. Okay, I'm just going to try to nip it out. And I want to leave some wire on the part too, because I want to test the part. Practically jumping out of there. At 16 volts. Okay, let's see if we can get our, where'd my meter go? Let's see if we can. Yeah, I'm one lead down here. Hope that wasn't interfering with the test. Okay, put that on there. What is that? Fruit fly flying around in here? Oh, why would I have a fruit fly down here? Okay, I got them on there. Here we go. I'll just come back and test it perfectly. See? It's 11.3 microfarads. It's ESR is 1.2 ohms. And the V loss, whatever that is, 1.6%. Well, it doesn't sound terrible to me. The fact that it's reading high here, 11, when it's supposed to be 10, and these things aren't precise, but you think as it gets older it would get lower and lower, not go up. And I found in the past that when you're testing capacitors and they're a little leaky, a lot of testers will read them high. So we'll go on the basis that this guy's bad. We'll stick another one in there. 10 and 16. I think I've got those guys.